All right. So as you were listing out your practice activities, these are the practice activities that I tend to see in math class. And I kind of broke it into two parts, in class and out of class. So if you just kind of look down through the screen and kind of give yourself a mental checklist, but I bet you're checking multiple ones on the in class and you're probably checking multiple ones on the out of class. And you're doing more than some. Now, some are going to be a little more grade level dependent. High school teachers aren't really practicing around U-shaped tables, where that's pretty common at the elementary level. So we're practicing. So the nice thing about this technique is it can fit into just about any of those activities. So in this case, I'm not really asking you to do something to add something on to your already full plate. I'm actually just having you swap out something on your plate. So instead of getting a serving of carrots, get a serving of mixed vegetables, and we'll talk about that analogy here in just a little bit. So the main reason that we are focusing on this technique is to try to flatten that learning decay, that forgetting curve. We need to flatten that as much as possible. Now, it'd be nice if it was 100% straight across, but that's just not realistic. But even if we gradually get it down like this, we have really increased the amount of information that kids are forgetting. So the purpose of this technique is retention. So one of the big things that I'm going to focus on is there are four purposes to teaching math. The first purpose is initial acquisition, so practice that follows your initial teaching. The purpose of that practice is to help the kids acquire the concept or the skill. Then you have any kind of practice activities that you do after it's already been learned, and you're wanting them to retain it. Then there's also build fluency and automaticity, and then generalization. We're not dealing with those second two. We're just going to deal with the first two, acquisition and retention. So what the body of research has really shown us with the retention work is there are three key things that are critical for an activity to help with retention. The first one is timing, sequence, and then this free recall paired with feedback. We're going to zero in on the sequence. I did there's another module that I did on the timing piece. We're going to zero in on the sequence, but you're going to see we're going to leverage some of that timing even with this technique. So there can be some overlap. But what we're really going to dig into are what are called practice structures. In other words, what is the sequence of problems that kids work through? Now, whether this is from the board, in a game, computer practice, a worksheet, or out of the book. It's the sequence that we have to pay attention to for this technique. So in other words, what does problem 1 look like? What does problem 2 look like? What does problem 3 look like? Now, I'm not looking at like the progression from basic to more advanced, which is pretty common in most of the textbooks, but what does problem 1 look like? What does problem 2 look like? What does problem 3 look like? That's what I want us to kind of zero in on. So right now, this would be a good time for you to pull out some recent practice you gave the kids. Now, whether that was carpet time for kindergarten kids or a worksheet for the high school or computer practice or textbook, whatever it is, pull it out. And I want you to look at problem 1, problem 2, and problem 3 and describe it.